Okay, good evening. Welcome to
MinuteMath116.
MinuteMath116. Unfortunately, this is take 2 because I drew the picture wrong. So a second ago, we got halfway through this problem before I realized I drew the picture wrong. So we got to start over. Wham. So this is not the Minute Math problem. This is back up. So this is the problem from the 5 triangle math guys that we really like, and this is another awesome triangle problem. Now, we had some cool ones last week, and we haven't talked about geometry that much, but this is a fun way to learn geometry, I think. So last week, we talked about the area of a triangle is 1/2 base times height, right?
Yep.
And base times height just means the length of the base, and then how high the highest point of the triangle is above that base. And it means straight down, so you don't have to be on top of the base. It can be far away from the base, right? So it's not, this formula is not just for a right triangle. But to find the area of any triangle, what we do is we just find the base, and then we find how high it is, okay? Now, this is also true, by the way, no matter how this triangle gets spun around. So I can't spin the board, right? So can you spin yourself? Yeah, right. See, if you look at it that way, the height comes down and the base is over here, right?
Yeah.
Okay, so the problem that they proposed today that has only the area of a triangle needed to solve it is they drew this funny shape, and then they shaded in this middle part of it, and they said find this area. So all we know is that part's 8, this part's 6 from here to here. We don't know how long this is. We know this part here is 5, and this is a right angle. This part's 3 over to here. We don't know how long that part is, and we know that's a right angle. We've got to find the shaded area. Okay?
Yep.
So, you don't know how to find the area of funny quadrilaterals, do you? I don't have a funny quadrilateral formula there. So what's the first thing you should try to look for?
Well, triangles.
Let's try to find some triangles, so maybe we can cut it in half. Okay? Now we're going to see how this helps us. How many triangles do you see in there?
No, the whole picture just
just a shaded part.
There's 2 triangles.
Okay, let's label them 1 and 2. 1 and 2. Okay, let's talk about the area of triangle 1. Do you know any formulas for the area of triangles?
Right here.
1/2 base times height. Okay, great. So this is where we got to last time when I realized I drew the picture wrong.
Yeah.
Okay, so we're back. Whoop! Okay, so what do you want to do now?
Well, we know the base. Triangle 1, the base is 6.
Okay, awesome. That's great.
But the height is this.
What's that?
It's 5.
Okay, so what's the area of triangle 1?
It's 30. 15.
1/2, 6 times 5, so 30 divided by 2. So this area is 15. Okay, great. And what about triangle 2?
Triangle 2. So the base is 3 and the height is 8.
How do you know the height's 8?
Because these lines share the same point.
Ah, very good. So it looks just like this, right? It's just turned.
Yep.
Okay, so what is the area of triangle 2?
It's 1/2 of 24, which is 12.
Okay, so the area here...
Hey, we labeled them 1 and 2 and I can do the numbers in.
That's true. Maybe they did that on purpose. No problem, these guys are pretty clever. This area is 12. Nice. So what's the area of the shaded region?
It's 15 plus 12, which is 27.
Good job. It's amazing that you can find the area of that just by only using the formula of the area of a triangle. That's a really cool problem. You want to see some complicated ways to do this?
No.
No. When I was reading about this problem online, I found some very complicated ways to do this, but your way of doing it is absolutely right. Good job, sweetie. Good job.